Hi, I'm going to try something new. I'm going to try to explain feathers and dinosaurs to you via video. Mostly because I have tried to explain via writing before, and people still usually have confusion. So let's talk about feathers and dinosaurs. First off, we're going to start with the bottommost question of it all. What are feathers? Feathers are a type of integumentary structure. Now, what this means is that they are a structure on the surface of the body. Other types of integumentary structures include scales and hair. Now, feathers right away, we know that they are not the same thing as fur because they develop from a different protein. Fur is made of alpha keratin, feathers are made of beta keratin, and they develop from different portions of the epidermal layer, meaning that they grow out of different parts of the skin. So knowing that right off the bat, feathers are a group of structures that develop from the epidermal layer that all share similar features and a similar evolutionary line. Now we know pretty well how feathers evolved. They started out kind of like fur. They were a single filament. Over time, they kind of became multiple single filaments, all branching from a single point. This is what we would call downy feathers today. And over time, they formed those pinnaceous feathers that we're all familiar with, meaning there's a vein in the middle and then barbs going out to the side, and they all kind of neatly line up with each other. Those are called pinnaceous feathers. Technically, the single filament structure is called a protofeather. However, I'm going to call it feathers for the remaining of the video because we don't really have a very good idea of when pinnaceous feathers actually evolved. We used to think that it was in Penaraptora, if you look in the diagram I've provided. And yeah, SVP just happened, the Society of Vertebrate Paleontology annual meeting conference thing, and it's looking like ornithomimosaurs might have had pinnaceous feathers. You'll note that they're kind of far away from being Panaraptorans. They are in fact Maniraptora forms, so we're not entirely sure when pinnaceous feathers evolved. We do know, kind of, when protofeathers evolved. Okay, given all of that, next question. What is phylogenetics? So nowadays we don't use Linnaean classification anymore. We don't use kingdom, phylum, class, order, family, genus, species. We don't. Which sucks because I actually ended up memorizing that. Okay. What we use is this thing called cladistics, which basically means that we map out how animals are evolutionarily related to each other. Linnaean classification is based on traits. We don't want to do that. Evolutionary relationships are a more meaningful way of showing groupings of animals. How do we determine evolutionary relationships? Well, yes, we use traits, but here's the thing. Oftentimes in Linnaean classification, we would use single traits and make them more important than others. The way cladistics works is that we take a sum aggregate of all the traits that we possibly can, and we look and we see which groups share more. It's a more quantitative process than a qualitative one. For example, mammals are warm-blooded. Birds are warm-blooded. Yeah, they have way too many other differences for them to be classified in the same group. Each one evolve their warm-bloodedness separately. Similarly, the ancestor to dinosaurs was probably bipedal. The ancestor to humans, bipedal. We have way too many other differences. We are not part of the same group just because we're both bipedal. Does that make sense? So, okay, now that we know that we use evolutionary relationships and similarities to construct trees, we can use those trees to determine when traits that we didn't use in the analysis actually evolved. So, we know that birds are dinosaurs. We know that they evolved from dinosaurs. We've known this for a while. Okay, that's not what this video is about. It's about feathers. So, given that, we can look at the patterns of feathers in dinosaurs, and we can try to figure out when they actually evolved. Now, with this sort of thing, the simplest explanation is probably the more likely one. So, if two organisms are very closely related on a tree, it is more likely that any shared trait evolved in their common ancestor and was retained. Conversely, it is more likely that if a group that is closely related loses a trait, but multiple groups other than it keep it, that it just lost it. It's actually very easy to lose a trait. There's a lot of different ways, like deletions and transversions and all the rest of that. However, if two organisms are very far apart, and they both evolve a trait, it's more likely that they evolved it convergently, meaning they both evolved similar but not the same versions of that trait. So, now that we know all the simplicity of it, which dinosaurs had feathers? Well, we know for a fact that Maniraptor forms on had protofeathers. We know that for a fact. We know most, if not all, Coelurosaurs had protofeathers because we have found fossils with feather impressions. On that note, T-Rex, because it was a Coelurosaur, more likely than not feathered. However, I will admit that there is question about it. You know what animal there isn't question about? Velociraptor. That thing had feathers. We even have not feather impressions, but we have portions of the bone that would have lined up to pennaceous feathers. Okay? They would have linked. The thing had pennaceous feathers. Okay. Knowing that we know that, what about other groups? Well, it's a little bit more confusing for the rest of Theropoda. I think I heard something that says that there might be an Avoraptoriform. I'm sorry, that was not right. Avetheropoda found that may have had pennaceous feathers? I don't know. It may have had feathers, though. So that's another widening of the group of feathered animals. And everything before that point is just kind of murky. But we know that some groups were scaly. This is a moot point. Why? You see that other group, Ornithischia, that's not anywhere closely related to birds or theropods within Dinosauria? Yeah, we have protofeathers in Ornithischia. Specifically, we have protofeathers in basal ornithischians, and we have protofeathers in neornithischians, which is a more advanced group. Meaning, protofeathers were a thing in this group. It is more simpler to assume that it happened once than that it happened twice, especially since feathers do not fossilize easily. They are delicate structures. They don't want to fossilize. It is more likely that we have more feathered animals than we're finding in the fossil record because they don't fossilize well. It's why we don't really have good numbers on many organisms that don't have hard body parts to fossilize. It's because they don't fossilize. It's very hard to know things about ancient life because we are constrained by what we have the fossil records in. So it is more likely than not that more dinosaurs were feathered than we know. So Colindodromaeus had protofeathers. Given this, I will also say that pterosaurs, the close cousins of dinosaurs, they are not dinosaurs. Pterosaurs are pterodactyls to most of you. Stop calling them pterodactyls. They're pterosaurs. They had these things called pycnofibers that were filamentous hair-like structures. You know what else is a filamentous hair-like structure? Protofeathers. What's more likely, that a filamentous hair-like structure evolved twice in this group, or that an ancestor had it and they retained it? Yeah, it's more likely that pycnofibers and protofeathers are the same thing, and this type of integumentary structure evolved at the base of this group called Avemetatarsalia. Given that, if they're not the same, then it's actually pretty reasonable that it could have evolved 3 times. But simplest explanation is the best one. Simplest explanation, it evolved once. Yep. But given that, we do know some dinosaurs were scaly. It's very easy to lose a trait. Much easier than it is to gain it. So there are multiple groups of dinosaurs that we are aware were scaly. These include titanosaurs, pretty much all sauropods, hadrosaurs, and carnivores, things like Carnotaurus and other abelisaurs. Now I will give you that this is still kind of a little bit iffy because if pycnofibers and protofeathers aren't the same thing, then, well, crap, dinosaurs probably weren't ancestrally feathered. But more and more feathered dinosaurs are coming out each year, and it's way more logical to suppose that they were. A paper came out in 2014 that was trying to claim that dinosaurs weren't ancestrally feathered, but pretty much all of their analyses that gave this were assuming that pycnofibers weren't the same thing, and that's just bad science. You're telling me that something that similar couldn't possibly be the same thing? No. And so that's why we can't really trust Barrett at all. We need more analyses. And when they included pycnofibers as the same thing as protofeathers, their analyses returned that it evolved once and that dinosaurs were ancestrally feathered. Okay, knowing all of this fun stuff, whew, which dinosaurs were feathered? Well, we can pretty much say the basal dinosaurs were, so sauropodomorphs, maybe. The closer you get to sauropods, less likely. The closer you get to the basal dinosaur, more likely. Theropods, unless they were ablesaurs, I would say put some feathers on them. Less on bigger animals, more on smaller. Don't put pinaceous feathers on anything that isn't a Maniraptor form now, apparently. And as for ornithoshins, we know that hadrosaurs were scaly. Quills on early members of Ceratopsia and Pachycephalosaurs are okay because we found quills on the tail of Psittacosaurus. I don't know if you should really put them on advanced Ceratopsians because we have scales of advanced Ceratopsians. For thyreophorans, I can't pronounce that word, I'm sorry. aka things like Ankylosaurus and Stegosaurus, we have scale impressions, but I wouldn't say no to them having kind of tufts of fluff in the armpits, kind of like modern giant mammals, elephants, you know? Just vestigial things. And yeah, that's feathered dinosaurs. We know this because we have fossils. This is not a matter of debate or interpretation. This is just what we've gleaned from the scientific evidence and looking at cladograms. I hope this was helpful. I recorded it twice. And yeah, have a lovely day.